And according to this, I'm live, so if I'm annoying you through the internet, good for you. If I'm not yet annoying you through the internet, good for me. We'll figure it out. I believe the technology should behave somewhat today. Notice a qualifier of somewhat. With that, earlier I was helping someone who happens to be around, and the individual could not for the life of me tell me why I can divide here. Is there a division property of equality or a division property of association or commutative? No, there is no division property that I'm using here. I'm using the of equality. Thank you. And for saying that, my tongue has been freed, for the math gods have been appeased for now. Let's just hope they don't get into the whole sacrificing our gardens to them. That would be horrible. My garden barely grows as it is. All right. So today we will be going into chapter 7. And I got to say something. The other day, part of my stuff I do as a teacher and whatnot, I have to relicense. Well, part of that is here and there I get to watch videos of myself annoying the rest of the world. That's what I do for a living. I annoy you all with math and say, all this fun stuff. Anyhow, as I watched this video, maybe I'm the only one who gets a laugh, but I thought I was hysterical. I thought it was awesome. You know, the whole diverting from the point yet getting back to it, you name it. So if you think I'm doing awesome, great. If not, don't write me. I don't want to hear it. So we'll go on ahead and we're getting into chapter 7. Now, as we wrapped up just before the Christmas break, we went on this huge, I'm going to teach you how to factor, I'm going to teach you how to algebra, and we're going to make stuff work, okay? Let's get through this. And we knuckled under and we made it happen. Everyone came back from break and I said, 6 what? Oh yeah, we'll do 6.1 maybe 2. I don't know, I'm kind of bored with this. We already went over it. And so I went to 6.5 and said, here you go, enjoy. If for any reason you're struggling with that and the pace that we're moving, go back, check out the videos before the Christmas break. They can help. Ooh. No, that's not a school appropriate question. All right, anyhow. With that in mind, yes, I am missing a student. No, it's not that student who's missing. But if I had to guess, it would likely be that person because that person's good at throwing off my whole lesson. Anyhow, back as to what I was saying, we kind of flew through it this time around. If you're feeling lost, whatever, look at those videos. Come in, I will help you. Remember, in math, everything goes back to what do I know? Inductive versus deductive reasoning. I want to do my best to use that deductive reasoning. Shelve the inductive reasoning. And use this to make determinations about the world. Is it always true that? Blah. Whatever blah is, if you're asking yourself, is it always true that? You're learning math, and that's my favorite question. If you're expecting me to sit here and go, and now students, please turn to page 453. As you can see, the Nixon model of Keynesian economics was a boon for somebody, anybody. Yeah, good Ben Stein imitation in my head, probably not so much for the camera. With that in mind, I'm here to help you on this journey. But if you're struggling with the math, that means you may be missing something. You know, here we are, we're going full steam ahead. Do you have both oars in the water? Do you have issues with crabbing? You should Google that, it's kind of fun. I mean, reality is, it doesn't matter where we're having our issues, we can strengthen them. But if you're running into the same problem over and over and over and over, I recommend you do that style of problem until you are bored with it, till you fall asleep every time you look at it. If you hit that point, that's where you start to be like a math person. And everyone thinks you're smart. Really, I'm not super smart. Doesn't work that way. I'm just super diligent. I'll work through something a million times if that's what it takes for me to understand it. That's the trick to mathematics. For those of us who weren't born with it. I'm talking 99.99% of humanity here. All right. Here we go to graphs. Oh, happy day. This brings me to why in the rubric it says a sin against graphing and it takes away all your points. If you turn in a graph in my classroom that is not on graph paper, it's wrong. It's wrong. You'd get more enjoyment from feeding it to your dog, I promise. Because at least then your dog would be burping confetti and you'd get a chuckle. You give it to me, I won't shred it, I won't publicly humiliate it, I just won't grade it, I'll hand it back. All graphs go on graph paper. Now with that, some people are like, ooh, do you prefer this size, that size? I don't care. Graph it on graph paper so that you do a good job. All lines need to be drawn with a straight edge. Who here has a ruler right now? Awesome. Who doesn't? Let me show you something. Most of us carry this around. Look, I have insurance card. I got all kinds of cards in my wallet. Straight edge, right there. You don't have any cards, any plastic, anything like that? You don't? Well, this is a AAA card. It only works if you're standing by the vehicle with it. You need to have the card. That was not a commercial for them. Although it turns out maybe it is. Who knows? I'm not endorsed, though. They don't pay me. But if they'd like to make a donation to my classroom, I'd like some colored markers. Check card. Rewards card for every time I get a soda. That's right. Oh, yeah. 1 in 10, they give me a free one. It makes me feel like I'm saving money, even though in reality I'm not. I'm sure people get the general notion. Use a straight edge when you graph. We will go over the finer details of graphing as we get into this. Graphing! Again. All right, objectives. To be able to plot points in the rectangular coordinate system. If I give you an address, I want you to be able to get there. And for anyone who's like, address? Yeah, we're going to give you a point. It's an address. If you know how to find addresses, you're happier. If you don't, uh-oh. Graph equations in the rectangular coordinate system. Ooh, that looks like fun. Use function notation. Awesome. I sense I'm getting some fear. If you're struggling with that, I'd like to point out, in math, when you run into really hard stuff or really ugly stuff, you can use what we call use substitution. When it's ugly, you substitute, right? When I was taking calculus the second time, we had this great professor. He was from China. Now, with his culture, he didn't understand cross-culturally how things sounded or looked. So he pointed at the board with his middle finger. I'm using 2 fingers because I'm in contract and I don't want to get in trouble. And as he was talking about it, he started talking about how you had to pay attention because you have, once you have done so, you have f of u. So imagine this person with a Chinese accent sitting there, f of u, pointing with the middle finger. The rest of the class is sitting there stone-faced trying to write everything down. It's my second time through calculus, so unlike the rest of the class, I'm sitting there just busting up. I'm about to fall in the middle of the aisle, rolling with laughter. Function notation is not that scary, okay? It's not an f of u. It's really not that bad. It is f of all kinds of things, f of x, f of g, whatever we want to look at. And we can go into that. But no, we're not going to start off with f of u, so you'll be fine. We'll make it. No stress, no worries. Graphing functions. Woohoo! Who here wants to be able to graph a function? Yay! Everyone's raising their hands because I'm brainwashing them. They're compelled to. They get chocolate if they raise their hand for these questions. All right, use the vertical line test. Ooh, interesting. We will be able to tell from vertical line test, am I a function or a relation? What? Well, am I a function or a relation? I'll give you the test to find that out. Obtain information about a function from its graph. From being able to read the graphs, you can learn a lot. You can also play with them and mess up people's calculators. So if you're ever bored, you'll know some of the things you can type in. Fun, fun, fun. All right, here we go. We use the Cartesian coordinate plane. Now, if you notice, it's kind of weird. The first quadrant is right here, where both addresses are positive. So if I go to 1, 1, I'm going to this point right here. 1 over 1 up. And the reason for that is, up until now, historians disagree a little bit, but it wasn't widely accepted until after like the 1700s, and someone's going to Google this and say, it'll show up in the comments, you're an idiot, you know. But they didn't agree that there were negative numbers. They were like, what? Negative numbers? Well, show me -1 meter. -1 gram. -1 anything. That doesn't make sense. And a lot of our math was based on geometry. So the first coordinate is there where everything's positive and happy. Your x is positive, your y is positive. We're happy. Next, we added the others. Why? Because we said, okay, we'll put up with the negatives. So we get to torture the rest of humanity with negatives. Woohoo! Why is it called quadrants? Well, why is it called a quarter? Wait, what? Why is it called a quart? There might be something to this. Audi Quattro? Wonder why all these words. Okay, anyhow. So second, we've got our x values are negative, but our y are still pretty happy. They're going up. The x is just kind of negative. Then we have the third. Oh, they're both so negative. That's where we just put the negative nullies just down there. Then we have the fourth quadrant, which is where your x is positive, your y is negative. Your x is your horizontal line. So when I'm looking at it, x goes this way. My x goes this way. That's right. Chops right through. When your x breaks up with you, you feel like you've been cut in half. It's horrible, horizontally. Right? Your y is more of a karate chop for the people who don't know how to karate chop. Right? Seen an old 80s movie, the ninja pops out and y-axis. Okay, maybe not. Maybe I dreamt it, who knows? With that in mind, y-axis, vertical, x-axis, horizontal. And I'm done waving at people because every so often I'll start waving, and then people start accusing me of goose stepping and doing horrible salutes. I don't know what's wrong with them. Why would anyone do that? The very center of the Cartesian coordinate plane, 0, 0, is the origin. Or as Sheldon would describe it in Big Bang Theory of his spot, in 3 dimensions, 0, 0, 0. Happiness. Sheldon spot. The origin. 2-dimensionals, 0, 0. 3-dimensional, 0, 0, 0. The very center of the universe, where someone like the character Sheldon Cooper would believe they resided. The center of everyone's universe. Each point has its own unique address. The x comes first, followed by the y. And when I'm trying to remember this, I just remember x comes before y. Now, on this, I want to point out that it says real numbers. We are not graphing imaginary numbers on this. You have to use something different, and it's kind of obnoxious. Look at that. X, Y. Interesting. Don't worry, we'll get some practice with this. All right, here's your practice. Yay. All right, we're going to stop here for just a second, and we're going to get to the part of the activity where you need to have your Chromebook. Please sign into your Chromebook and bring up the browser. If you're at home, just bring up another tab. And I will give you a Google URL, and you can participate along with what we're doing. Don't worry, your results don't show up on my screen, so you don't need to worry about being embarrassed. More importantly, can't troll that easily in this classroom. It happens. Don't worry, the technology will make up for any trolling that you miss out on. Oh, for the goodness gracious. My goodness. I don't want you full screen. I want you to go away. All right, let's do this. Haha. Yay, it behaved a little. This is from earlier. Well, that's the wrong page. There we go. You know that moment when you get really mad at technology? I just did this. For the love of all that is ugly. I just did this on the other. Our tech guys keep updating things, so it makes things a little obnoxious. Just a little. Okay, let's see if that'll do it for me. If not, I'll have to type in my password and cry a little. goo.gl / capital FMJ lowercase z.
That whole address right?
Yeah. Oh, come on. Oh, my. Why are you fighting with me? You know what's crazy is I tested this all out. You guys may not believe me, but I did. I tested it all out yesterday. I had no issues with it. I don't know why this is choosing to behave the way it is. Well, it's apparently not going to let me do it the way I intended, so we'll just do this. What's wrong? Switch your network to SWATC guest. I'll help you with it here in just a minute. I made this all beautiful and incorporated it. FMJ. Okay, so if I may drive for just 1 minute. Okay, I was hoping to do this through the SMART program, but it's fighting with me. So on this, we'll be using this graph a little bit here and there for the next few days. If for any reason you're kind of like, Matt, what are you doing? You are more than welcome to have fun with it. You can play with this. You won't upset me. If you manage to break it, I'll be impressed. So I just want to go down here. I'm going to turn on number 7. So when I've turned on number 7, I just click this dot right next to number 7. I've got preloaded in all these things on this graph. That's why I took the time to put this together with a link and everything. Make our lives easy. Are you able to get there? And were you able to click on graph 7? Perfect. Now you'll notice on my screen it's blue, on yours it may be a different color. Color is not the important thing. What happens if I move the Y slider here? What happens if I move that over? Which direction? Is it horizontal? So if I'm moving it in the positive direction, it goes here. What if I set that equal to 0? That's an interesting thought. Y equals 0. Oh, it shifted over a little. Look at that. You walk away from it, and it's just never done fighting. See, that's where I had it, right? And then I turned around and I moved. What happens if I put this one to 0? At the address 0, 0, I'm at the origin. So when I'm graphing by hand, there's a few things I need to make sure of. One, that I use real number lines to indicate these go on forever. If you don't believe me, you can scroll in, you can zoom in right here. See how far that goes. I mean, if I were to zoom in on that, how far do you think I can go? I've got that point 0, 0, right? Well, how far can that beast travel? Hey. Oh, this is taking too long. Oopsie, I wanted to stay on that 0. Is there a limit to how far I can go? It's getting awfully small, isn't it? Okay, well, let's zoom out. Is there a limit to how far I can zoom out? No. These lines go on in each direction forever. So if I'm just representing them, I'll put little arrows on the end just to represent that. So that, hey, everyone knows. That's a line. Not a line segment, it's a line. Because lines go on both directions. It's not a ray. It's not starting at one point and going on the rest of the way forever. So there we go. Kind of fun, huh? For me. So here, I've got this point. Now, when you put any point on a graph, you want to label it. Period. If you put the point on the graph, you label it. It doesn't matter what your point is. I don't know why it started fighting. Oh, I did the wrong one. These are not attached to that. They're attached to other things. So here, if I look at this, and there we go, I still want the label to appear, whatever points I'm doing. Do not cut squares in half. Change your scale. Instead, make it so that each square in between is a half, whatever, but don't cut them. Don't do fractions, it gets ugly. So next, let's have a look here. We've got this weird formula. Now, some people may remember this, some people may not. But if you've seen this before, it's kind of funny. Y equals mx plus b. What's happening? I move m, and what happens? If I were driving my car along that line, would the engine work any harder than it otherwise would? On a freeway? No. So there the slope's 0. What happens if I do this? Ooh. Is my car's engine working harder to go up this line? Yeah. So we call that positive. What about now? Negative. M is slope, and slope is rise over run, which is also your change in your y over your change in your x. And we'll get to play with that a little bit more. So on this, you can play around with m. Now I wonder what b is. What happens if I move b? Ooh. B is our y-intercept. That's where it touches or crosses the y-axis. Isn't that fun? So on this, feel free, especially as you're doing your homework and things. You can check your points on here. You can check your equations. Very useful. I've got this all set up for you. My goal is that you start to see the differences in choices made with it, and more importantly, that you start to have a little bit of fun. I mean, math is fun when you look at it. That's not the screen I want. All right. So see here, they've got it, and they're showing again. A is negative 3, 5. I'm just going to go over 1, 2, 3 to the left, then up 5. It's just telling me my directions. If I were looking at it in terms of north, south, east, west, same kind of thing. So some ways we do it similar to the way we do streets. Now, a relationship between two quantities can be expressed in two variables. Here we have y equals 4 minus x squared. We have a solution of an equation in two variables is an ordered pair of real numbers following the properties. The x-coordinated is substituted for x and y is substituted for y. We obtain a true statement. So with that, if we have two variables and we plug in whatever we've solved for, it'll be true. Now, do you guys remember we talked a lot about the different types of solutions? That's going to come up again. The graph of an equation in two variables is the set of all points where the coordinates satisfy that equation. So on this, they took and drew a picture by plugging this in. Remember, y can be changed out with f of x. So we could call this f of x is equal to 4 minus x squared. They put in a negative 3. When they do, they get 4 minus 9, which is negative 5. And this is how they get those points. Then they draw a picture of it. And they connect them. This is a parabola. They're kind of fun. If an equation in two variables yields precisely one value of y for each value of x, we say that y is a function of x. So when we look here, notice each x value only has one y, right? I only see 4 here. I don't see another dot anywhere on that. The notation y equals f of x indicates the variable y is a function of x. And notice the notation f of x is read f of x. And if it was f of a, it would be f of a. If it's f of u, it's f of u. F of v, f of v. U and v substitution are used in. So on this, it wants you to graph the functions f of x equals 2x and g of x equals 2x plus 4 in the same system from -2 to 2 inclusive. Notice it says integers. Does that mean fractions? No, we don't have to. So -2, -1, 0, 1, 2. And when you plug those in, you end up with sets of ordered pairs, and bam, you get 2 lines. Do you see how these two are related? They're the exact same function except for g of x is up 4. Its y-intercept is up 4. That's it. They have the same slope, which is up 2 over 1. Between each point is a ratio of up 2 over 1. Rise over run. Here we have the whole g of x, and this is why we have f of x, g of x, and h of x. We like to put them on the same graph and compare them and see how they look. It's a lot easier to tell them apart if we change it from f of x and f of x instead to f of x and g of x. Makes it easier. Vertical line test. On this, I'm going to draw a line vertically. If it touches or crosses the graph in more than one place, it is a relation, not a function. So if I draw a line vertically here, it touches here, nope, here, and here. Therefore, it fails the vertical line test, meaning it's a relation. Circles are a relation. Look at this sideways parabola. Relation. Function, function. It'll pass the vertical line test. For each x input, there is only one y output. It doesn't matter where you draw the line. If you cross in more than one spot, it is a relation, not a function. You will be asked to do those in today's homework. And on these are the story problems, which get fun, and we'll play some more with those later. Are there any questions on the things we've gone over today? Why are you fighting with me? Do you see what I'm dealing with? No, don't do that. Exit full screen. All right, so chapter 7.1 is looking like gravy to me. Looking happy. What was that? To me? What does that mean? You don't seem happy. You seem very upset with that notion, and I don't know why. It seems very happy. All right. So here we go, 7.1. plotting points. And on this, I assigned 1 through 53 odd and 55 through 62.
55, 62.
Yep.
All.
Yes. Evens included. You sound so happy with me right now. And I wanted to point something out as soon as the technology will agree with me. For the love of all that is ugly, why are you doing this, machine? I really do need a designated driver on this. Don't I? Think about it. How often it fights with me. Something. I don't know what to do. I find that depending on the day, it gets more and more fickle. I don't want a screenshot. Hey, Arturo. Only if you need to. Why is this not doing that? There. I don't even know if I have my keys on me. There you go. No, no, no. Why are you doing this, evil machine? The computer's trying to restart to update software. I'm like, dude, I'm in the middle of something. Half of the fun of tuning into my channel is seeing me struggle. What was that question about? Hey, what do you know? I can get out, finally. Why are you fighting with me? Exit full screen mode. Yeah, no kidding. That's okay, you can leave the page. There we go. Hey, what do you know? We're going to get somewhere. Alright. Even though that doesn't work proper. There we go. Let's see if that's... Oh. I don't feel like answering that question right now. Sorry. You just have to wait. Okay, so let's have a look here at some of these exercises. When I look at number 23, the first thing my brain says to me is, self, hey, pay attention, look at this. You gotta really know what you're doing here, because you got problems. Come on. Oh, why are you, see, it's right, I have problems. So when I look at this, I need to make sure that I only graph on graph paper, right? That's not the right one. No, go away. No one asked you. There it is. It's in a mood today, I think. Because every time I go full screen on this screen, I can't see the whole thing. All right, let's see here. There we go. Oh, don't be rude. Where are you? Let's start at that. I had this all set up yesterday and I erased it. When I was young, I was very tech savvy. I used to make fun of old people who struggled with things the way that I'm struggling right now. I think this is karma. There it is. Sometime before I'm ancient. Come on. There we go. Well, that's not it. How did we get off that base? Oh well. Graph on graph paper, don't do what I'm about to do or I'll yell at you. There we go. So let's look at number 23. All right, it has y is equal to x minus 2. And the instructions are, select integers for x from -3 to 3 inclusive. Notice it said select. It didn't say I have to do all of them. It said select. So I just need to plug in some integers, right? Let me introduce you to my favorite 3 integers. These will come up again and again. If you're graphing, they're very useful. My favorite x values to choose from on the majority of things I run into are, you ready for this? Drum roll, please. We have 1, thank you, 0, -1. Those are my favorite 3 points to plug in, unless it's a fraction. If there's a fraction, then I like to put in a whole number that clears it. From that, I'm going to get my y values. If I plug in a 1, I get 1 minus 2. That gives me a... If I put in 0, I get... And if I put in -1, I get... Now from that, I can graph this. I'm just going to take and put these points on the graph. So on this, assuming I use a straight edge, I do my Cartesian coordinate system. Now I'm just going to take and plot the points on my graph. So I'm going to say, okay, I have a 1, I have -1. So I'm going to put that 1, comma, -1. Next point, 0, -2. And next I get -1 and -3. Then I'm just going to take my ruler. So where are you, ruler? I'm going to grab out my ruler. I don't know why this thing's fighting so much today. I'm going to move my ruler so that all of these points are now, come on, lined up. Hey, come on. It always works so much better when I press it on the computer and it's not live. You know what? Come on. Way to go the opposite way. Once I have my ruler in place, I draw a straight line connecting all 3 lines, indicating it. Then I'm going to write f of x is equal to x minus 2. I just substitute in f of x for y. And I'm done. That one seems difficult, but it's really not. Okay, so now we have the tables, which we see here. You plug it in anywhere there's an x. And remember, when you're plugging stuff in, very important to do so in parentheses. So when we look at number 47, we have f of x is equal to x squared minus 1. Then we're just going to plug in the points. -2, -1, 0, 1, 2. So I'm going to say, okay, f of -2 is equal to -2 squared minus 1. Negative 2 squared is 4. 4 minus 1 is 3. So that's going to be 3. And I'm just going to put that into my table, like so. I'm going to keep going with each thing. See, not too bad. Just plugging it in, evaluating it, seeing what I get. People look kind of upset with me, and I don't know why. I'm not sure what to do. Now let's look at number 55. Is it a function, yes or no? If I draw a line vertically, will it touch the graph in more than one place? So here it is. Where can I draw a vertical line and touch this line in more than one place? So yes, it's a function. Okay. Next. If I do... Ah, there might be something to that. What about number 58? If I draw a vertical line, I'm going to touch it in more than one place, therefore not a function. Because if I look at it, it's more than one y point for an x. Here we have the x value, right? How many y's do we have? 1, 2, 3, 4, 5. As many as you want. There are one x, multiple y's. Therefore, this is a relation. It's not a function. Okay. Ah, why aren't the diagonal? Here we go. Let's go along the x-axis. Okay. Name a place on this that I can touch and get one more y out of each x. If I draw a line vertically, I'm not going to. Therefore, this is a function. For it to be a function, it can only have one y for each x. So let's have a look at another, because this sometimes causes some real confusion. What about if I have something that looks like this? Now on this, people will look at this and go, no, not a function, because if you look here, at this x, we get a 0. At this x, we get a 0. Therefore, it's not a function, because I have the same y on a different part of the graph. But that's not what we're looking at. This x has its own y. This x has its own y. We're looking specifically for how many y values per x. So this is a function. While if we look at this one, draw a vertical line, and we end up with, right here, we've got 1x, 2 y's. Therefore, it's a relation. It is not a function. We draw a picture of it. Vertical line, no. Relation, not a function. Does that make sense? One x, 2 y values. Relation, not a function. Function has, for each x, it has its own y. Vertical line test tells me if I draw a vertical line and it touches this in more than one place, it's a relation. So yes, you were right on those curves and things. But be careful with that, because sometimes you're going to get a function that looks a little strange. I mean, if you look here at my friend the cube root of x, I mean, woo. This one is a function. Exactly. So when we're looking at these, that's what we're looking for functions. Relations, those are your circles, your sideways parabolas. Those weird things. Kind of cool, huh? So on this, just a quick cheat sheet. Let's go through it. 55 function, yes or no? Yes, I agree. 56 thumb pole, yes, no, maybe. 56 function, yes or no? I agree, yes. 57 function. I disagree. It is a function. It's a horizontal line, but it would pass a vertical line test. All right, 58 function, yes or no? No, it fails the vertical line test. More than one y output for the same x input. Ooh. 59 function, yes or no? No. 59 is not a function. 60 function, yes or no? No, it's not. 61 function, yes or no? Yes. 61 is a function. Just because you see parabola, don't assume. If it's got its hands towards heaven or towards the, underworld, doesn't matter. It'll pass that vertical line test, therefore it is a function. 62, function, yes or no? No, agreed. And you guys were afraid because I assigned the even ones in that section. Now let's look at number 45 real quick, because 45 I could see causing some heartburn for some people, so why not have a look at it? We'll go on ahead and full screen this and hope it behaves. So number 45, it says, and I quote, evaluate each function at the given value of the variable. So we have 45. And we have f of x is equal to x over the absolute value of x. Now, absolute value is distance from 0 on the number line. So it doesn't matter if it's positive, just take the number along. If it's negative, drop the negatives. No negatives allowed over here. Absolute value, you have to go over there if you want to be negative. We aren't going to play. So with that in mind, we have a is f of 6. And b is f of negative 6. So now, what do I do? Well, it's a function. I'm given a value here. Whatever I see here, f of 6, I'm just going to plug in. Anywhere I see an x, I'm plugging in a 6. So f of 6 is equal to 6 over absolute value of 6, which is going to be 1. Right? Happiness? Do we see it? Ooh, that's a great question. I would put 6, 1, that point. Well, no, just 6. It would be over 6, up 1. We go x direction first. X comes first in the alphabet. So this is my x, and this is my y. Now I'm going to do f of negative 6. I love that you're thinking about graphing these. Most people think about doing the math and start crying.
Well, it's all about graphing, so you might teach us.
May as well, right?
So it's gonna be over 6 down there.
So on that, we've got -6, -1. So it'll be to the left 6, down 1. We go to the right for positive, left for negative. Think of it this way. Negative things are left for dead. They go to the left. To the right is always positive. Those of us who don't like southpaws, you know, we're always talking about how right is the best. It's always good to sit on the right hand at a banquet of the guest of honor, right? On the left, you're left for dead. It's social end of your life, whatever you want to look at it as. So on these, we're just plugging it in. Please don't forget to use parentheses. Notice up there, I plugged it in, didn't use parentheses because the type I was doing. But when I did like the x squared minus 1, there I used parentheses. As for being able to graph these quickly, that uses the mother function knowledge. That is not included in this book. So I plan on going off the rails and teaching it. I'm just going to teach you all how to recognize the mother functions. We'll be going over them. And on that, we'll get into shifts just barely so that when we hit them in trigonometry, it'll make more sense. Although the trig we're doing is very basic. I don't know that we'll do much phase shifts. I can, oh, but no, it's not in there. We'll just play with the SOHCAHTOA. All right, now let's get to answering. No. Horrible. No, the question. I wouldn't answer that in person off the clock. All right, if there's any other questions that are pertaining to academics, go on ahead and send them in. Feel free to ask your questions, whatever else. Know that your chat is censored till I approve it, so no one else will see what you just said to me. It'll be our little secret. Okay. I wonder how this came out. It's fighting with me. It won't stop. Stop recording me. I don't want to be recorded anymore. The joys of playing with technology. It always fights. Come on. There we go. Yes, I am aware that black shirt and black pants don't match. I had an issue this morning. Thank you for pointing that out.